Math can be a difficult subject to apply back into the real world. Let's face it, we will never need to calculate the temperature of a potato after being pulled out of the oven. But there's always an exception to every rule, like needing math to find a washer's volume. The disk method can boggle some minds with its revolving curve, radius, and its need for cross-sectionals and integrals and pi, and I'm getting ahead of myself here. Let's just start with the basics. The concept of a two-dimensional graph expanding to having multiple dimensions is a toughie to wrap your head around. So let me try to explain it to you. I'm going to first show you a two-dimensional graph. This graph has a y-axis and an x-axis. Many people use this graph on a daily, but for this video we're going to be adding another dimension to it. Once we do that, it now becomes a three-dimensional graph. Now I can move from left to right, but also forward and backwards. This is the graph we'll be using today. The disk method's procedure is simpler than it sounds. We first need to start off with some kind of curve. Let's say y equals the square root of x. Now comes the revolution of the curve. If we were to take the graph and turn it on its side, we would get a shape similar to a fishbowl. The side of the bowl is going to represent our curve. So from here, x equals 0, and all the way up here, x equals 4. If we were to shoot a line straight through the middle of this bowl, that would represent our x-axis. If we rotated our line all the way around this axis, we would get the shape of a bowl. Now that we have our shape, let's find its volume. In the disk method, the volume equation is v equals a times dx. A circle has the area of pi times r squared. R, aka radius, is the curve's function, which in our case is the square root of x. Now that we have the area, it's time to plug it all back into our volume equation. The integral of the area is the volume of this shape. Therefore, our volume is 8 pi. You may be saying to me right now, yes, now I can use the disk method, but Madison, when will I ever need to use this in the real world? You may never look at a ball like this and try to find its volume using the disk method. But I can assure you, there are many people out there with professions that use this concept on a daily. Math is everywhere. It's in our environment, in architecture, in our electronics. Having a better understanding on just one method of many brings you closer to understanding. Thanks for watching. I hope you learned a little bit more in the realm of calculus today. And remember, don't underestimate the influence of math in your life.